following differential equation. So we got x square y prime. So y prime means dy over dx, just the derivative of y with respect to x, plus xy equals 1. So we got y prime, and the coefficients are just function of independent variable, because here solving means finding the function y in terms of independent variable, which is x. So y is dependent variable and x is independent variable. The coefficients are just the functions of independent variable. That means this is a linear ODE, linear differential equation. So we know that when we have linear means, let's say dy over dx or y prime plus some function of independent variable px y equals some function of independent variable qx. When we have in this form, in fact we can divide through by x squared, and we can always write in this form. Then to solve this linear differential equation, we multiply both sides by the integrating factor. That integrating factor is, we generally denote by mu as a function of x, is e raised to integral of this px. Okay, let's do it here. So we need to write this in this standard form. That means divide through by x squared. So x is positive, that means we are not dividing by 0, so that's legal. So y prime, let me write dy over dx. I am dividing through by x squared plus x over x squared, which is 1 over x, and I got y left there, equals 1 over x squared. Now if we compare this with this standard, so px is 1 over x. Okay, that's kind of optional. But now we need to find, and let's denote this by star for future reference. Now we find integrating factor, IF integrating factor is e raised to integral of this. Okay, if there is a negative sign, we need to take that into consideration as well. So, but this is 1 over x dx, e raised to px dx. Okay, now let's integrate this. So that is e raised to antiderivative of 1 over x is natural log of absolute x, but our x is positive, so we don't have to write absolute value. And e and natural log, they are inverses to each other. That means their actions cancel, just x. So now we multiply 1 throughout, okay, on the left side, on the right side by x, by the way. Okay, so when I write in different color, that's optional, don't have to show. When we multiply through by this star by x, okay, by this integrating, then let me write down, when we multiply, then star, that equation becomes, it will be automatically satisfied, so you don't have to write. So what happens is the left hand side will be always derivative of dependent variable, which is y, times the integrating factor, which is x. Okay, if we multiply through by x, and if you find the derivative of y times x using the chain rule, okay, then you'll get this one, by the way. Anyways, when we multiply through by this differential equation in the standard form by the integrating factor, the left hand side is automatically derivative of dependent variable times integrating factor is equal to right hand side 1 over x squared times x. If you multiply 1 over x squared times x, x1 copy x cancel from top and bottom, so 1 over x. Now we integrate both sides. Okay, that means we are left with y times x equals integral with respect to x, okay, 1 over x dx, and we can integrate this, which is natural log of absolute x, but x is positive, so don't have to write absolute value, plus some constant of integration, so y times x. And the final step is to isolate y. For that, we divide both sides by the integrating factor. So y equals divided by that. So natural log of x over x plus c over x. Okay, do not cancel this x. This is argument for natural log of x. This x is a factor. Okay, final.